take here is that interest is just money that's paid at a particular rate. So that's the word that goes there. Simple interest follows a linear model, whereas compound interest follows an exponential. You will see the difference between the two formulas and how simple interest basically doesn't, stack up as much and as quickly as compound interest will. Because if you even think about the word compound, that means that it's more than one. So you're putting interest on top of interest on top of interest, which means it's more interest paid. But for simple interest, this is basically when you have a situation where you get an interest rate, you borrow something for a certain amount of time, and then you're just saying how much you're gonna pay back. They usually split payments up, and for the most part, simple interest is what you're gonna get when you get a loan from a bank or if you buy a car. They go ahead and finance you at a certain percent, bam, you pay that amount back on top of your payments for what the car's worth. So let's start with the student loan first. Student loan has a 3% interest rate. You borrow $5,000 for 9 years, how much are you gonna pay? Well, if you're just talking about how much you're gonna pay in the interest, then you would just calculate that amount multiplied. But we want to get the total amount, the final amount that's going to be paid. So this here formula is what we're going to use. You take the principal, which is 5,000, and we're going to multiply it times 1 plus our rate. Our rate is 3%. Remember, the rate has to be written as a decimal. So I heard somebody say 0.03. That's right. But you're multiplying it times the time. And one of the things you need to note is that it's not just time in months, it's specifically your time annually. Y'all, annually means per year. So the time per year. It says you're going to borrow for 9 years. How much are you going to end up paying back? Total amount. This is multiplication. 0.03 times 9. I just use a times because I didn't feel like doing parentheses times parentheses. All right, so put this in the calculator. You can put the whole thing in the calculator. You don't have to do these 2 steps. What I'm about to do is I'm going to take 1 plus, and then let me see if I multiply that, I get 0.27. Using the order of operations, y'all, you would multiply the rate times the time before you add the 1. But if you have a calculator, graphing, even scientific, you can put all of it in there at one time.
That's right.
Did you get 6,350? That's right. Total amount paid back was 6,350. And like I said, usually when you're paying amount back, they give you monthly payments. So they just take the amount that you're going to have to pay back total, they just split it up into however many months you're going to, pay it back. You're not going to stay there, are you? Okay. I'm switching over. Theo took out a loan, a bank loan with 4% interest rate to pay for a boat. If he didn't pay back the loan for 5 years and ended up paying them back $1,800, how much did he initially borrow? This time, it's not asking for the total amount that you are paying back because it's telling you that he's paying back a total of $1,800. It's asking for what he initially borrowed. If you want to talk about the initial borrowed amount, we are referring to what we call the principal. We are looking for the principal balance, meaning the amount that you borrowed to begin with. So it's basically saying, okay, this time you're going to put everything in place, but solve for the P this time. So I'm going to substitute all the values they give us with the total amount going first, 1,800. And then I need to put a variable for what I'm trying to solve for. But the rest of it comes straight from the formula here. See, the formula is 1 plus R times T. So this is gonna be 1 plus, and the rate, we gotta make sure we write it as a decimal. Where was that? It's 4%. There you go, 0.04. And the amount of time was 5 years. Think about this for a minute. When you put this in the calculator, you're gonna have to put what's in the parenthesis in there. Bring down your 1,800 for your initial step. There's nothing you could do with that on that side, so just bring it down. But then on the other side, you wanna go ahead and add, well, multiply first, I'm sorry, and then add the 1. Tell me what you get when you get that. Yep, that's it. So I'm not multiplying, but I'm looking at the principal amount times 1.2. Think about it. You know, solving an equation is inverse operations, right? So if the principal times 1.2 gives me 1,800, how am I going to find the principal? Divide, yes. I'm going to divide both sides by 1.2 because that's the number that's touching the variable that I need to get rid of. And then in the calculator, from top to bottom, I put 1,800 divided by 1.2, and that will give me the principal amount, meaning the starting amount that was borrowed. Yep, $1,500. When you look at interest is one of those things that when you talk about credit, you really want to have an idea. Long story, in the long run, it's actually better to not pay interest. But then, in terms of building your financial credit and getting that credit score and footprint out there, you do want to have some things that you borrow and use credit to pay back. Of course, it's going to be an interest charge. But the way you can get around paying interest charges, my uncle taught me this a long time ago. I don't know why my daddy didn't tell me, but anyway, my uncle taught me that if you borrow money or use your credit card, as long as you pay it off within that 30-day period, they don't charge any interest. If you wait past that, then you're paying interest on whatever it is that you borrow. So that way, you get the benefit of building your credit by using the credit and keeping your credit debt ratio low. So what I've always been told, bad credit is actually sometimes better than no credit, because if you don't have a credit history at all, they're like, well, how do we know whether they're going to pay back? We don't know. It's like taking a gamble. So I'm saying, because you guys are seniors, I think once you turn 18, they start pushing credit cards at you. They might even do it before then. I don't know. Do they advertise credit cards at your age now? Yeah. Okay, think wisely about that, because they're extraordinary amounts of interest that's being charged, and you don't even think anything about it, because at that moment it looks like free money. Nothing's free, honey. It's not free. You paying for it. And the small picture, sometimes it's like, I want, so you get it right then, and then you end up paying for it later. So that's pretty much how interest works when it's simple interest. But compound interest is a little different. Compound interest is when, let's say, you invest money, right? Go to the bank, and they say, all right, well, we're going to pay you this amount, but we're going to compound it annually or semi-annually, meaning a certain amount of times a year they're going to stop and they're going to add more interest to everything you have in the bank. So that means if they're paying you interest, they're going to pay more interest on top of that. So it's like it grows quicker, it gets larger faster. That's why this one's exponential, because it's growing at a certain rate exponentially. But here's the thing, key words, bless you, that you need to think about when you are using this formula is if they're telling you that the interest is being paid annually, because annually means how many times in a year, y'all? Just once. Semi-annually, how many times? 2. What about quarterly? 4 times a year. Monthly?
12.
What about weekly? 52. Essentially, there are 52 weeks in a year, okay? And daily, not talking about leap years, it's going to be
365.
356 days in a year. Good job.
Oh.
156.
It's 360. Lord, I put 56. I'm sorry. My brain, I transposed the digits. I'm sorry. It is 365. What was I doing? Sorry. No, that transposing digits is real. Come on now. What I was thinking. Thank you for keeping me straight and not just sitting there writing down like, oh, maybe I was wrong. No, you're not wrong. There's always been 365 days in a year.
So, these words right here, the back.
Right, because your formula for compound interest is more complex. And you would think it would be because you think about compound, it's more. So with compound interest, you're still going to have your total amount and your principal right here. But then to calculate that amount for the interest, it's going to be 1 plus the rate divided by the number of times they're compounding it. But then they're going to raise this to the number of times they compound it times the number of years it's being compounded. That sounds so complex. Thankfully for you, there are some of these compound interest calculators online that you can substitute all this in. But to learn the basis of how the math works, that's why we're doing this. Because obviously, it would be more difficult to figure out how much money interest would be invested when everything's online. But this is just you learning the math behind the math. So it says I have a savings account with a fixed annual interest rate of 3% compounded semi-annually. If Paul invests $5,000, how much will he have after 6 years? Think about it like this. They're saying, okay, after 6 months, we're going to stop and give you some interest. But then 6 months later, they're going to give you more interest on top of the balance plus the interest that was already there. So that's actually a win-win. Go ahead and set up your formula. And the final amount is the A equals, the principal was 5,000. What I'm going to do this time, since there's a little bit more to look at, is I'm going to write down the R, the N, and the T. We already know the principal amount was 5,000. So my rate for the R is 0.03 or 0.03, either or. The number of times I'm compounding it, remember this little portion right here? It's going to be, was it semi-annually? Yeah. Semi-annually is 2 times. So my N is 2. But then the T represents the number of years. So that's going to be 6. Now that I got those 3 numbers all together, I'm going to apply them to the formula here. So we scroll up a little bit. See your formula? There's a lot going on. You're going to have parenthesis and then 1 plus the rate, 0.03, good job, over 2, because that's the number of times it's compounded. But then at the top, you want the number of times compounded times the number of years overall. What's wrong? You understand the rate? Okay, so one thing we threw in new was the number of times compounded. And since it says compounded semi-annually means 2 times in a year. And you know that because I also have this right here, see? Feel free to look at that section if you're forgetting how many times a year they're compounding. Now, you can put the whole thing in the calculator once more. You can do that. Or you can start simplifying it down. Sometimes I like to go ahead and write down what's going to be in my parenthesis first. I don't know why. So the 1 plus 0.03. Can I go back up?
No.
This way, right here? Okay. Yeah. So if I'm simplifying this before I put all of it in the calculator, this is what I like to write down first, and then I put the rest in there. Because sometimes you get extremely large numbers that you need to make sure you calculate it correctly. And this, over 6 years compounded at 3%, it's pretty decent.
You lost.
Almost 6,000. Did you put the whole thing in the calculator?
You lost me before that.
So you know that I'm just putting the numbers right here. The formula is where I'm putting all the numbers. The 1, see, it was right here. And then there's a plus sign. But then the rate is over the N. Well, the R is my rate, so I'm putting 0.03 over the 2. Then you raise it to the power of n times t, so 2 times 6. Just put your numbers in place of the variables, all you gotta do. And then from there, since this might be a little confusing, I'm just gonna say you can put the whole thing in. Don't even worry about, put this whole thing in there. Well, not the A equals, but just this part. Put that in your calculator and jump right to the final answer. Talk to Boston.
Is the R, the N, and the T you wrote on the side, is that always going to represent those letters, that value?
You mean, will these numbers always be the same? No.
Oh,
The R will be whatever your percent is as a decimal. The N will be whatever they're telling you how many times it's getting compounded, okay? So no, it will not always be 3%. It will not always be 2 times compounded. It will not always be 6 years. Those numbers will vary based on what they're telling you in the problem.
so how did you get your N then?
Okay, so the N comes from the number of times compounded. I covered that part up, so let me just go back right here. See? How we get the N value is based on these keywords. Are they compounding it annually, semi-annually, quarterly, monthly, weekly, or daily? This says it's being compounded semi-annually. So when we refer to semi-annually, that means 2. So the N is 2.
Okay. And you got like your T for 6 because in 6 years is asking how much?
Right.
Okay.
The T right here for the time, maybe I should have explained this more. In the formula, time is always going to be in years, okay? So when you look for the time, you're looking for whatever it says in there for years. So did anybody get on here $5,978.09? That's what I got. $5,978.09 is what we'll get out of that investment. This is why a lot of people invest in stocks, because you get exponential growth when you are gaining. Of course, it's also exponential loss if you lose in the stock market, but you're always going for the benefit. So I got this time a loan. Oh, what's the question? You really don't want to get a loan that has compounded interest, but it happens many times. Applying for a loan with an interest rate of 4.2% compounded monthly. The loan was $10,000. How much will we pay back after 4 years? We got lots of details we need to find. So I'm going to make this a little more clear this time. I kind of skipped steps before. And we'll start with the values that's given for the formula P and the R, the N, and the T. I'm going to get all of those values right here. I'm going to write down this, and this, because I don't want to lose anybody. So the principal, the P, that's the initial amount. What does it say the initial amount is? 10,000. The R is the rate. You have to look for the percentage, but then change it to a decimal. Don't tell me that it's a decimal. It's a percent. Change it to a decimal. Thank you. It's going to be 0.042. Because this number here has a percent sign, which means I'm moving this decimal over 2 times. Percent means out of 100. So 4.2 divided by 100. There's my rate. My N, we're looking for the number of times it's compounded. What does it say? Compounded when? Monthly. So the N is 12. Thank you. And the T for the time is in years. What does it say? 4. Now put all these numbers in the formula, okay? Okay. See, I slowed my roll down this time. So I've got the A equals 10,000. How do I know what? When you say adding, subtracting, you mean like in the parentheses? Always adding. Because interest is something that's being paid. It's always, like if you're thinking about how we did growth and decay, It will always be a growth, never a decay, because you're paying it out. So I've got 10,000 and then 1 plus the rate, 0.042. Over the number of times it's been compounded, 12. But then you're gonna raise it to the compounded times the years. So that means N times P is 12 times 4. You put the whole thing in the calculator from here over. Take your time, because the most difficult part, getting the answer, is typing it in right. The calculator does all the rest for you. So,
Every time.
what? I'm gonna write what I have on this. And y'all can tell me, does anybody else get this answer? Ooh, with my calculations, that's what I got.
Yep.
I'm sure I got it too.
Yeah, for this, I have quite a few of these to practice, mainly because the compound interest problems and just the simple interest, the most difficult part is knowing what formula to use, I guess. So you have to be able to look for those keywords. Go ahead and flip over to the back. We'll do some of these together and then I'll let you do the rest on your own.
You should do one for the rest